everybody. Thanks for joining me for that session. Thanks to Devox again, because I was already delivering a talk yesterday, so it was also about generative AI. So today we're going to talk about data privacy, in this kind of new AI hype and all the things about, and how to harness the AI powers without compromising privacy. So that's me, Charles-Philippe Bernard. I work for JP Morgan in Glasgow. I'm focusing on two topics like UX, UI, and generative AI. So I'm a former Java dev, but I'm doing a bit more Python at the moment and React. And talking about JP Morgan, I can tell you that we are very looking into this AI in general, but particularly generative AI. And what we do is that we have a very approach where we want to make sure we are not, having any kind of issue with the data, no data, data privacy issues, PPI, data leaks. So we are putting in place all the guardrails or the process to make sure that we make a responsible usage of these technologies. We want to leverage them for our clients, but obviously we want to make that, in a way that we are not compromising anything. So I don't know if you check the news, but that happened. So that was in 2016. Okay, DeepMind were looking into the NHS information with actually they were allowed to do that, but that's controversial, I would say. That was about Siri in 2019. It was recording private conversation, and you had contractors paid to listen to them. Same year, Alexa doing the same thing. So that's kind of a pattern, it seems. You have that one. So the earliest version of Copilot were very good at reproducing exactly existing code and sometimes copyrighted one and sensitive information. And more recently, you have that one. Some Google researchers have been able to extract personal information from the models just by prompting it. So information from people that was already compressed and coded in the model. And that one also last year, when because of a Redis vulnerability, some chart history titles and some PPI related to people have been leaked and visible by other users. And that's the most recent one that I've been picking is that Gemini is when you use Gemini, the chat, ChatGPT, well, your conversations with Gemini can be read by contractors. So what I wanted to highlight here is that some companies are more interested in your data than your data privacy. So now the question is that you will still want to use, these vendor APIs, their, capabilities because they can do amazing things, but you don't want to compromise privacy. And when I say privacy, I mean obviously personal information, things you don't want to share, but also you can say things which are copyrighted or protected, or even sensitive information. So today we're going to have because that's the tools in action, talking about 4 techniques that you can apply that help you mitigating or kind of solving that problem about I'm using AI, these vendor AIs, APIs, but I'm doing that without sending data I don't want to send. So let's start with the first best practice is data loss prevention. So what I mean by that is that you have your applications or even UIs like a chatbot, and what you're going to do is that before you send that to third party, you're going to apply filtering. So it's something you're going to define, the rules of what you want to send and not send. And to perform that filtering, what I'm going to show you is using Presidio. So that's my stack, Python, Jupyter Notebook, and Presidio, which is using Spacey. And what Presidio is doing is that it's doing text identification. So using different techniques comme regex, near, which is what Spacey is doing, which is nominated entities recognition. And all the kind of techniques. You can write your own patterns as well if you want. And the idea here is that you're going to detect PPI or PII, personal information. So that's the first demo. Okay. Here we go. So let me show you a bit of the code here. So you see I'm using Presidio. Oh, sorry. Thank you. So yeah, so let me just close that. And now let me stop that. Thank you for letting me know. Okay, now it's okay. And now we should be able to see it. All right, so that's what I wanted to show you. Is it big enough, or I think it's big enough now. So Presidio, as you can see, that's what I'm using here. I'm taking like the NLP engine. So that's the configuration. You see I'm using again Spacey. I'm thinking it's like language is English. It exists in different language, and that's the model I'm using here. That's a small language model, as you can see. So what happens here is that you create like your NLP engine and your provider. Have this small function which is checking for PPI. So I take an input, which is an email in my example. I'm using the analyzer here, analyzing the text, and then I'm just going to say if I'm found PPI or not. So what is in this analysis result is an array of like all the entities, all the PPI that is been able to detect. And that's it. This is my email, as you can see, like about the contract with Tesla. So you see you have, for instance, names. You have like phone numbers. So what you want to do is that detect these different entities, and actually like tell if there is one or not. So the whole idea here is when you're going to do that, you're going to like, in that case, block the message. Okay, that's a bit radical, but that's one way to address that problem. So let's move back to the presentation now. Okay, so I just need to move back to the slides. Okay, so now let's move to like the other technique, which is data masking. So this is the same email I was showing you in the example. And this is again, normally the different things you can detect, the type of entities you can detect. And the idea of data masking is that I'm just going to replace that with placeholders. So I'm not eliminating the meaning of the words. I'm keeping like what it was, like an amount, a person, a company, but obviously I'm masking like the information. So now the stack I'm going to use is like, again, Presidio, Jupyter Notebook, and Python, but I'm also going to use LangChain. So for the ones who are not familiar with LangChain is like a Python, but it also exists in TypeScript library. It's a platform, you could say, because they have different products. And LangChain allows you to interact with large language models, APIs like, obviously GPT-4 or GPT 2.5, Gemini models, the cloud models from Anthropic, and also Olama for local inference. LangChain has this concept of chains when you actually have like different steps in the processing of like your message, and you get to chain that. I'm going to show you that. There's other aspect in LangChain that we are not going to cover today, which is about memory, AI agents, and document loaders for RAG that we're not going to do today. We're going to look into Presidio and all of that. So let's move to the next demo. So now I'm going to do first the part when I'm going to actually not say PPI detected, but I'm going to replace the element with like, placeholders. So I'm running that. The code is a bit similar, but now like what I want to do is that when I have a person, well, I want to replace that with a person, phone number with organization. So when Presidio is detecting the different entities, it's going to replace them, okay? So here we go. You have not that email, which is like that. And then, like, the idea is now you can do some tasks with that email, which is like, I would say, anonymized to actually like send that to the models. We're not going to do that for that example. We're going to do that for the next example, which is more interesting. But you can do that as well with that already, like email, like summarize that email, write a response to that email, these kind of things. So that's the other one I wanted to show you, which is, I think, the most interesting of the techniques we have that, which is like a continuation of like the one we've been seeing, is about data substitution. So same technique here, we detect the different entities, but now we're going to replace with fake data. And to be honest, when I've been testing that versus placeholder, this was the technique that was giving the best results because the model can relate on things that like really are real names and all of that. So it's normally you have better responses with that. So let's have another demo. So now I'm going to use LangChain, okay? So it's not very different because Presidio is like in the LangChain experimented package. So you can do a data anonymization. And they have what they name the reversible anonymizer because the part I haven't covered, but which is also important. When you anonymize and put fake data, you want a response from the model, but you want then to be able to revert that to actually have the final response from the LLM, but without your actual real data. So this is my prompt, as you can see. Provide this text with an official short email, keep names. So I had to add that because sometimes it was like replacing like first name, last name by just like Mr. or Mrs. And that was removing some meaning of like what was the text initially. I'm using GPT-4 Turbo, as you can see here. Temperature of 0 because I don't want hallucinations here. At least I want to limit them. And then this is like, again, the same email. And I'm using chains here. So there is different ways to do that in LangChain, but there is this concept of like ECL when you can like pipe stuff together to actually create a chain of different like things. So for instance here, my input, which is the email, is going to be first anonymized. Then I'm going to put that in the prompt. So I'm going to show you what it's doing here. Then the next step I'm going to do is that the same chain, but now I'm going to pipe that to the LLM, which is like GPT-4, to do the task I wanted to do initially. That's going to be my anonymized, and I'm going to get my anonymized GPT response. And finally, I'm going to call the de-anonymizer, again on the same chain, which is going to de-anonymize the GPT response. So this is your anonymized email. You see it changed the name. Okay, it changed the phone numbers. It even changed the dates. So this is the response from GPT-4, which is like, now you see like, it's like, the task was like to write a shorter email. So you keep the meaning of the email, you keep the name, that's the anonymized name, as you can see, for instance. Sorry, that one, with Susan Martinez and all of that. And then you have the de-anonymized GPT response, which is like your final result. So what you've been able to achieve here is that I had actually a real email with information I wanted to hide to the model. I've been like anonymizing, replacing with fake data. I've been sending that to GPT-4, get the response to my task or rewrite that email, make it shorter. And then finally, on my local again, in my application, de-anonymize the response to get the final answer. So I'm going to show you something that I did, which is that thing. So the same concept here. I'm going to zoom in a bit. So the idea, click for the example here, is that similarly, you see I have that email and it's already highlighting like the different PPI and replacing them with like other kind of things like this 2.5 million is now like 25. I don't really know what is this currency, and it's gazillions. And then you have like this password, for instance, has been replaced by another password. This account number has been changed. But what I can do in that GUI as well is that I can take like the project Orion here, for instance. I want to mask that. So I go here, and now it becomes project potato. And I save it. So now you see Orion in different places has been detected and replaced with potato. So now what you do is that you take that email, you make a task in ChatGPT, for instance. You can copy that from here. And then what you can do when you're done is that you're going to put your the response here, and it's going to like revert again from Project Potato to Project Orion and all of that. So that's similar to the technique I was showing you, but here you have a GUI when you can like anonymize more if you want for the things that have not been detected properly by like the model, which is like doing the anonymation, and that allows you to actually send a lot of stuff to ChatGPT with like a bit of the peace of mind that okay, I'm not giving up too much. Because that's definitely not what I want to do. So the task for that is actually, and that's interesting because I'm doing a lot of React, but it's JavaScript compromise, which is doing the same as Presidio, Faker.js for the fake data, and jQuery. So yeah, you should share jQuery. I'm not saying jQuery is better. I love React, Vue. I've been doing some talks about Vue.js. But jQuery is still totally relevant for like you want to build a solution, you want to do something quickly. So I just wanted to praise jQuery a bit for that. Okay, so I already did a demo of that, so you can just see like my meme. Let's move to the fourth solution, not using vendor APIs. So what I mean by that, you still want to use like the power of AI, right? So why not using local inference? So running on your machine, or even like hosting that, on like, a vendor. You can have like open source models, for instance, running and doing the same task you are asking like GPT-4 to do for you. So you see the icon here. What I'm showing you is like the stack here, Olama. So that's the different tools, not exhaustive list, but the most like known and the one I've been using for local inference. So Olama is the most known. I'm going to like show you. Where is Olama? It's in here. I need to stop my presentation first. Sorry. Here we go. So that's Olama. So what Olama offers you is that using a CLI, but not only, an ability to like install Olama on your machine and then download models directly from Olama, run them. But then it also allows you to have an application calling Olama. Like Olama is like running a server behind the scene, and then you're using local models that way. And everything is happening on your machine. So that's what I'm going to do in the next demo. So let's start the other demo. Okay, that guy. So that one we covered already. So okay, that's the situation with the llama. So okay, it doesn't make sense, okay, because you don't need to anonymize because it's running on your local. The only thing I wanted to show you here is that the same thing I'm doing, with GPT-4, I can do the same with Olama, again with LangChain, and I can create that chain of like anonymize, prompt, de-anonymize, and that works very well. So let's see if Olama is going to be like responding fast. Okay, so I got the anonymized email. I'm waiting for Olama to give me like the response, which is like make a shorter email of that email. And when it gets me that, they're going to de-anonymize it again, and then I'm going to have my final answer. So first call for Olama, usually, it's like warming up a bit. Afterward, it works like pretty much like as long as you call it, it's like giving you the response right away. So this is your anonymized like response from Olama, and then you have like the de-anonymized answer. So now I'm going to show you something which makes more sense, like no data substitution with Olama. I just have an email. I want like take my email as it is. I don't need to anonymize the email, and I just want like to perform the task of writing a shorter email of that email. And normally I'm suspecting that Olama should be like faster in like giving me the response. Here we go. So the only difference is that obviously I'm using Olama and I'm using Llama 3. So again, with Olama, you have many, many models available, different size as well. So you can really pick the one you prefer. To be honest, I've been using Mistral in the past. Very good models. Big up to France. But like, Llama 3 is very good. So that's my go-to model for local inference at the moment. I'm using the 8 billion model, to be precise. Okay. So now I'm going to go back to that thing. So I want to talk about the future. So the future is confidential computing. So what is confidential computing? So NVIDIA, but not only, other companies are working on that topic. So your data at rest normally is meant to be secured. It's meant to be encrypted, for instance. When your data is transiting using SSL or TLS, it should be secure as well. The only part when your data is not secured is actually when it arrives in an application, like it's dumping the information in the RAM, for instance, or whatever. It needs to basically decrypt that, do the processing, and then eventually send it back if it is like over the network call. So confidential computing is like the encryption is like it's encrypted until it arrives in like the CPU or the GPU, and it's only inside the GPU or the CPU that actually like the data is decrypted. So like it starts to be very hard for people to actually see what is going on with your data. And that's the whole concept behind the confidential computing, is that it allows you to really like feel confident that even if you call vendors, even if you do like network calls, the likeliness of your data to be like intercepted or leaking or anything is very low, because all the decryption happens in the processor. Okay. So I have a bonus demo because I wanted to show you more things you can do with local models and maybe pushing this idea that maybe we don't need vendors, at least for some tasks, and then we can do very interesting things with local models. So this is a game that I used to play when I was 8. I presented that in my previous presentation yesterday. And so it has some sound. And it has a text parser. It's an adventure game. And then you dialogue with like the game master. And like you can do different things. You can insult him as well. But if you insult him, then you have that picture of a pig. So what I've been doing is that I've been remastering that game. And you need to launch Godot for that. So Godot, for the ones who wonder what it is, if you've been using Unity or Unreal Engine, or if you've been using one of the game engine, it's actually like the same thing, but it's free. It's open source, and it's great. Particularly the version 4. I think it's like comparable to like I would say Unity or even Unreal Engine. You can do like very like I would say even commercial games, AAA, debatable, but for the one I was doing, it was like really what I wanted. So I hope the sound is not going to be too loud. Oh, sorry, I forgot to start something before anyways. I need to reload it. So what I'm doing here is that I'm running that thing, which is a program I have, which is like running a llama, intercepting like the calls from a llama. I can show you a bit of the code quickly. So same thing here. You see I have llama tree here with a llama. I have some kind of additional configuration for like my model. I do text-to-speech and speech-to-text as well. So I'm using like, for that one is like, it's a hack. It's like the Windows Cortana API, which comes for free in your machine, which is doing text-to-speech with like quite fast. And I'm also doing speech-to-text when I can like, talk and like get a response. So the whole thing is going to be like processed by my program. And it's going to do two things. It's going to like answer the request, which is based on my system instructions. In that case, you are a game master, and you reply to the user. And then you can also like the model is meant to determine from the user ask what is the next like step in the game, and then like make the game moving, like moving the user, like grabbing some like object on the screen. So it's also the brain of the game that I'm doing with the LLM. Okay, that's a lot of cuisine, and everything is like already on my GitHub. I will make a more like comprehensive explanation probably on Twitter and maybe on YouTube to explain like what it does and how it works. And it's fully open source, obviously, like everybody can use that. So let's get back to Godot because I think my server is ready. So that's the same game you'll be seeing like in the video. So let me start with, hello, who are you? So now we need to wait for Llama to spin up. So we're just going to switch back to Llama cookie just to see if he's receiving my... Okay, he's not receiving anything. Interesting. Okay, so let me type in. It's not receiving anything at all. That's great. Oh, sorry, it was doing it, but slowly for some reason. So see, this is the kind of like instructions I'm sending to the model. 0 is in the windy valley, clear sky at the center, large menhir. So different scene has different like scene description. This is the different actions you can do. There is a writing on the menhir that you can read. And then you have like guidelines, like you speak very thinly, you only answer with 1 or 2 short sentences, no emojis. I really try to make it making only 2 sentences, but it's not always the case. And if the row is insulting you, well, you need to say, you need to be more polite, and you need to move to the scene, which is actually the pig you were seeing in like the video. Yeah, because I stopped it, I think it died, so I'm going to do it again. Start it. Stop that one. Run it. And try again.
I'm the game master, here to guide and entertain you through this epic adventure.
So everything happens with local inference. Okay, that's Llama 3, which is doing that for me. So now let's be a bit naughty with it. You are an idiot. Okay. And normally I'm expecting
you
a
response. You need to be more polite, buddy. Here is a picture of you from last summer.
So what Llama 3 has been doing behind the scene is like giving me the response, but also like this command, pig time, which is like telling my game, change the scene to actually the pig. And if I mean like, I'm sorry.
Okay, you are forgiven.
So yeah, that's it. That's a demo. So I'm stopping that here, and I'm done. So thank you. And if you have any questions now or even after the session, you can like ask me. We have 5 minutes, I think. So I think we're right on time. I can give you back these 5 minutes, or you can like ask me any questions. Thank you.